Hello, grade 9 learners. My name is Teacher April, and welcome to our science class. Today, we will learn more about motion. Before we dig deeper, let's try to review the grade 8 lessons on Newton's 3 laws of motion. Do you still remember it? Great! Let's start. Get your pen and paper. Write this one. Let's play Guess That Picture. This game is easy. All you have to do is to guess what Newton's law of motion is based on the picture. We have law of inertia, law of acceleration, and law of action or reaction. Write your answers in your paper, numbers 1, 2, 3. Let's begin the games. Number 1 picture. Time is up! Hope you are done writing. If not, you can pause or rewind the video. Okay? The first picture talks about the first law of motion that states a body at rest will remain at rest and a body in motion will remain in motion unless it is acted upon by an external force. This simply means that things cannot start, stop, or change direction all by themselves. It takes some force acting on them from the outside to cause such a change. This property of massive bodies to resist changes in their state of motion is sometimes called inertia. This is law of inertia. Did you get it right? Great job! Let's have picture 2. Time is up! The second picture shows the second law of motion. What happens to a massive body when it is acted upon by an external force? It states that the force acting on an object is equal to the mass of that object times its acceleration. This is written in mathematical form as F equals m and a, where F is force, m is mass, and a is acceleration. The bold letters indicate that force and acceleration are vector quantities, which means they have both magnitude and direction. The force can be a single force, or it can be the vector sum of more than one force, which is the net force after all the forces are combined. Let's go to picture 3. And time is up. The last picture is, you have a wild guess? Yes, it's the third law of motion, which states for every action there is an equal and opposite reaction. This law describes what happens to a block when it exerts a force on another body. Forces always occur in pairs, so when one body pushes against another, the second body pushes back just as hard. For example, when you push a cart, the cart pushes back against you. When you pull on a rope, the rope pulls back against you. When gravity pulls you down against the ground pushes up against your feet. And when a rocket ignites, its fuel behind it, the expanding exhaust gas, pushes on the rocket, causing it to accelerate. Did you get it all correct? Awesome! But if not, it's alright. It's better to review next time. So, what are we going to learn about today? 3 laws of motion? Nope. We are going to learn about the projectile motion. Do you know what's a projectile motion? Let's learn about that for today. So our learning objectives are the following. Define what is a projectile motion. Differentiate the 2 dimensions of projectile motion. Apply the concept of projectile in real life.
So let us define first what is projectile. A projectile is any object which projected by some means and continues to move due to its own inertia and mass. Okay? Now, let's try to know more about this one. Projectiles move in 2 dimensions. Since a projectile moves in 2 dimensions, it therefore has 2 components, just like a resultant vector. Okay? So we have the horizontal, which is from left to right, and the vertical, which is from upward and downward movement. So always remember that a projectile is a combination of two movements. We have the horizontal and the vertical motion. Okay? So it's a combination. That's why it is called projectile. Now, let's talk about the horizontal. In a horizontal component, okay, or in other words, the horizontal velocity combination, alright, there is a notion that it never changes, okay, never changes, so covers equal displacements in equal time periods. That means that the initial horizontal velocity, alright, is equivalent to the final horizontal velocity. In other words, the horizontal velocity is always constant, okay, so the speed of it is always constant. But why is it like that? Because gravity does not work horizontally to increase or decrease the velocity, okay? So meaning the horizontal velocity remains as it is. So if the given is 1 meters per second, therefore the final horizontal velocity is also 1 meters per second. How about the vertical velocity component? Okay, in this case, it's different, okay? It changes due to gravity. Does not cover equal displacements in equal time periods. Example, around 5 meters per second, and then it turns 20 meters per second, 45 meters per second, and so on and so on. So both the magnitude and direction changes as the projectile moves up, okay? The magnitude decreases and its direction is upward, okay? It moves down, the magnitude increases and the direction is downward, okay? So as you go down, it increases, but as you go up, it decreases. Alright, so let's combine the components. Together, these components, it produces what we call a trajectory or path. This path is parabolic in nature. When we say parabolic, it creates a round or curved structure, okay? The trajectories are the imaginary dots that you see in the diagram. So that is the path, and the curve that it is shown in the diagram is what we call the parabola, okay? So that's why it is a combination of horizontal and vertical. So what does this show? This shows that the horizontal and vertical are different, okay? They are different. In what aspect they are different? They are different because of its magnitude and direction, okay? So for horizontal, the magnitude and direction is always constant. As I've said, it is from left to right, it's constant. It does not change, okay? So in vertical changes its magnitude and direction. So as you go up in vertical component, the magnitude and direction increases. But as you go down, the magnitude and direction decreases, okay? So it's different, okay? So horizontally launched projectiles have no upward trajectory. That means it is just going down, okay? And it has no initial vertical velocity, okay? So nothing at all. So we can see here in the diagram, right? We have in here a cannonball, and the vertical velocity, which is the y. Always remember, if it is vertical motion, it has the y component, and if it is the x, okay, the x component, okay, the x is the left to right movement. So that means it is very important for us to know about these things, okay? These things are very important in our computation later, and I will teach you how to do it. Okay, so as you can see, the initial velocity of the x component or the horizontal motion is equivalent to 20 meters per second as it goes down. That means it is not affected due to gravity. However, on the other hand, we have the y component, which is the vertical motion or the vertical component. So it decreases or increases? It increases gradually as it goes down. So that is the difference between the two projectiles. Okay? Now let us analyze a projectile in two dimensions, and we need two equations for that. Alright, one is for the x direction, and one is for the y direction. Okay? So the y direction and x direction have different formulas, but we will follow these formulas for us to be guided. Okay, so just always remember that the velocity in horizontal is constant and the acceleration means 0. How, on the other hand, the vertical, projectile, or remember that since the projectile is launched horizontally, so the initial vertical velocity is equal to 0. Okay, so let's try to answer this horizontal problem. A plane traveling with a horizontal velocity of 100 meters per second is 500 meters above the ground. Okay, so imagine a plane traveling. At some point, the pilot drops a bomb on the target below. Two questions. How long is the bomb in the air? How far away from point above where it was dropped will it land? Alright, so let's try to know about this. So what do I know? Alright, so we have 100 meters per second, which is the x component, the vertical, alright? The horizontal velocity. Okay, this is the horizontal velocity, and the y, okay, which is the distance, 500 meters, and the y component, which is the vertical velocity, is equivalent to 0. Always remember it's 0. So the gravity is equivalent to negative 9.8 meters per second squared. And we get, just follow this formula, the 1/2 times gravity times t squared. Always follow the mathematical formula PEMDAS. Alright? And we get 10.1 seconds. On the other hand, using the same formula for the x component, just multiply the velocity and time, we get 1010 meters. Therefore, how long is the bomb in the air? That's 10.1 seconds. And how far away from the point above where it was dropped will it land? 1010 meters. And that is the answer. Okay. So in vertically launched projectiles, it's different. Okay. So in horizontal, it's constant, but in vertical, it is different. So the magnitude decreases as it goes up, alright, and it increases as it goes down. But the direction changes as well. Alright, so the vertical velocity decreases on the way upward, it goes up, and it increases on the way down. So there is no vertical velocity at the top of the trajectory. Alright, since the projectile was launched at an angle, the velocity must be broken into components. Okay, so we have the x component and the y component. Alright, so we have the x, which is the x component's velocity. The formula for that is velocity cosine theta, and for the y velocity, we have velocity sine theta. Multiply that, use your calculator to solve for this. Okay, so there are several things you must consider when doing these types of projectiles besides using components. If it begins and ends at the ground level, the y displacement is 0. Y is equivalent always to 0. So you will still use the kinematic number 2, but you must use the components in the equation. So this is the equation we used earlier, but we just added the angle sine and cosine theta in order for us to get the correct answer to this problem. So for the x component, we have the formula for velocity times initial, that's initial velocity times cosine theta. And for our y velocity component, we have velocity or initial velocity times sine theta. Alright, let's apply. A player kicker kicks a football with a velocity of 20 meters per second and an angle of 53 degrees. 3 questions: how long is the ball in the air? How far away does it land? How high does it travel? Alright, so the initial velocity is 20 meters per second. Alright, so that means it is constant if it is in in horizontal motion. So we have the following. Alright, so we will solve it. Try to look at it carefully. So the formula of the x component velocity, initial velocity cosine theta, that's equivalent to 12.04 meters per second. And for the y velocity, we have 15.97 meters per second. Alright, so now we have our vertical. Alright, vertical and horizontal motion. Alright, so we have our velocities now for the x and y component. This time, let's try to answer first. How long is the ball in the air? So the time. Alright, we need the time. Using the formula of y equals to the velocity of the y component times time plus 1/2 times gravity t squared. So you follow the formula and you'll get 3.26 seconds. Okay? Now, let's move to our x, which is the distance. So, what is the distance, or how far does it land? Okay, the distance of that using our formula for x is equivalent to the initial velocity, of course, times time. So that's 12.04 meters per second times 3.26. Where did we get 3.26? Okay, that is earlier in the time. Remember this one? Okay, so we get 39.24 meters. And that's how we answer it. Okay, now the last question. How high does it travel? Okay, so the maximum height or the distance has it covered going up. So all we have to do is use the formula. So you just cut it in half. Always follow the PEMDAS rule. So always start with division, multiplication, okay? Multiplication, division, addition, subtraction. 1/2 times gravity times t squared. And then you add it to the velocity and time as well. And you get 13.01 meters, okay? So that is our time, alright? So if you have any further questions, you can ask me directly or you can leave a message in our YouTube channel. Please stay tuned and subscribe. Alright, so we can also apply this in a real game scenario. I'm going to show you, alright, this one. This is a game which is very timely, the Angry Bird game, okay? It shows the parabolic structure. Okay, I'm going to play this first. Alright, so we have in here our Angry Bird and I'm going to shoot it with an angle of 22 degrees. Alright, so let's shoot it. Let's see if it can hit the pigs. Alright, I hit 2 pigs in a row. Alright, now let's do the second one. Let's measure. So the measurement of the next one is 65 degrees. Alright, so that is closer to our theoretical values. Okay, so we are going to hit the pigs upward and up in a way. Let's see if I can hit one. There you go. So in this structure or manner, it shows that 65 degrees and 22 degrees shows the difference. Just use a protractor. Alright. Alright, so we are down to our assessment part. So finally, please try to answer the following questions and you can send this one. So choose the correct answer and please show your solution as well. Okay, so also as part of our assignment or agreement, okay, make sure that You can create a 1-minute video showing the different projectile motions in 2 dimensions. Explain how this differs from one another and give the importance of it in our daily life. You can refer to the rubric using this link in the description box. Thank you so much and have a nice day. See you all.